So our next idea in electrochemistry or key point is electrolysis. This is not new to you A-level students because you looked at it in O-level. You looked at what electrolysis is in O-level, and you said that electrolysis is the decomposition of a compound in its molten or in solution, in its molten state or in solution by passing electric current through it. So long as a compound conducts electric current, and within the process of conduction, it is decomposed, and that compound is either in molten state or in a solution with another solvent. And the decomposition is caused by a passing electric current through that compound. Then that compound is an electrolyte, and the process is electrolysis. Are we together? What are the common terms we use in electrolysis? So the key word here is decomposition, molten state or aqueous solution, and call this aqueous solution. And then passing electric current through it. First of all, we have been looking at the term electrolyte. What is an electrolyte? We get it from this definition. It is a compound that conducts electric current. Compound that conducts electric current in a solution or molten state, and is decomposed as it does so. Any compound that conducts electric current in solution or in molten state and is decomposed as it does so is what we call an electrolyte. So there is no way a compound, for example, copper 2 chloride solution, if it is conduct electricity, then it must be decomposed into chloride ions and copper 2 ions. If that doesn't happen, then it can't conduct the electric current. Because we shall see later that these ions do migrate to certain points, which are the cathode and the anodes respectively. Now, there is what we call a non-electrolyte. That is a substance that does not conduct electricity in its molten or aqueous solution and cannot be decomposed by electric current. Then that one is not a non-electrolyte. It's a solution or a liquid, but it can even be a solid. But when dissolved in water or in its liquid state, it can conduct electricity. For example, sucrose, sugar. It's a non-electrolyte. In its solution, it will never conduct electricity. And so many others. You can think of petrol. Petrol is a fuel, diesel is a fuel, kerosene is a fuel, but they will never conduct electricity. They are very good fuels and sources of energy. Now, electrolytes can be salts, acids, or bases. Most of the electrolytes are salts, acids, or bases. Most of the electrolytes are salts, acids, or bases, and they can be strong or weak. So an electrolyte can be a strong acid or a weak acid. An electrolyte can be a strong base or a weak base. We cannot say an electrolyte can be a strong salt or a weak salt. There is no strong salt and weak salt. Salts are salts. And most of the salts, by the way, are very good electrolytes. Now, this brings me to another key point. What is a strong electrolyte? What do we mean when we say hydrochloric acid is a strong electrolyte? So these are electrolytes which almost completely ionize in solution. Which almost completely ionize in solution. Examples: hydrochloric acid in solution almost completely ionizes in solution. We looked at ionic equilibria and we said its alpha is almost 100%. Okay, its degree of dissociation is almost 100%. So it almost completely ionizes in solution. It's a strong electrolyte. So we assume these electrolytes do not contain unionized molecules in their solution. They are strong electrolytes. Okay. Sodium chloride is a strong electrolyte. It almost completely ionizes in solution from sodium ions and chloride ions. Sodium hydroxide, a strong electrolyte, almost completely ionizes in solution from sodium ions and hydroxide ions. How about the weak ones? What are weak electrolytes? These are opposite to strong electrolytes. So weak electrolytes are electrolytes which partly ionize in solution, which only partly or slightly ionize in solution. So always their ions are in equilibrium with unionized molecules. What do we mean by this? Let's look at ethanoic acid. Unionized ethanoic acid is always in equilibrium. That's what the partial arrow means, with its ions in solution. So such electrolytes are weak electrolytes. Okay. Their ions are always in equilibrium with the electrolyte. So other examples include ethylamine, ammonia solution, ethylamine, and many others. In others, to be general, all these ones include all weak acids and bases. All weak acids and weak bases are weak electrolytes. Then all strong acids and strong bases are strong electrolytes. Mind you, electrolytes can be ionic, like sodium chloride, or covalent. Do you know any covalent electrolyte? Sodium chloride is ionic, so it's a very good electrolyte. Did you know that hydrogen chloride is covalent? Yes, it is covalent. Aluminium chloride is predominantly covalent. But you may find that when these ones are dissolved in solution, they may tend to conduct electric current. However, let me detail what we call ionic electrolytes. They are made up of ions in the solid state. Sodium chloride, for example, in its solid state still has those ions. But in their solid state, there are strong electrostatic forces of attraction holding the ions together. Strong electrostatic forces. Even in the solid state, it is ionic. Even in the liquid state, it ionizes, it gives ions. But before being dissolved in water, there are strong electrostatic forces of attraction that hold those ions, making them not free to move. But when you heat them, when you heat the sodium chloride, then it becomes molten. And in becoming molten, the ions are free to move. What makes them molten? The energy obtained from heat. The energy got from heat is sufficient enough to break these strong electrostatic forces that exist or hold the ions together, making them free to move in the molten electrolyte. So that's the mechanism by which the ions are made to move and conduct electricity in the molten state. So in ionic electrolytes, the electrostatic forces of attraction are broken by the sufficient energy from heat that breaks those electrostatic forces to make the electrolytes molten, and hence making the ions free to move to conduct electric current. What happens when you dissolve in water? When you dissolve in water, still the crystal is broken. The electrostatic forces of attraction are broken. Remember, on dissolution in water of ionic compounds, there are two forces that take place, two energy changes that take place. There is lattice dissociation. I hope you remember that from thermochemistry, and then hydration. So the moment you dissolve sodium chloride or any other ionic compound in any ionizing solvent, first of all, the crystal lattice is broken. Is broken because the strong electrostatic forces of attraction are broken. Then secondly, the ions become hydrated. If water is used as the solvent, the ions become hydrated. If any other solvent is used, then we say the ions become solvated, or they become completely surrounded by the solvent molecules. If it's water, by water molecules. Let me hope I'm very clear on the two ways by which ionic electrolytes form free mobile ions that conduct electric current. Am I so clear, Muhammad? Okay, let's proceed to what we call the covalent electrolytes. Covalent electrolytes. How are they able to conduct electric current? These ones do not contain ions, by the way. I gave you an example of hydrogen chloride gas. It's a covalent electrolyte. So they do not conduct electric current in their gas. It doesn't conduct electric current in its gaseous state, but it will conduct electric current if it is in the liquid state or in solution. Now, such electrolytes have something in common. They have polar covalent bonds. In a way that one atom is highly electronegative, or is more electronegative than the other atom in the compound. For example, chlorine is more electronegative than hydrogen. So usually such electrolytes contain OH bonds, OH halogen bonds. Most of the covalent electrolytes have that nature in them. So they usually react with water to form hydrated ions. That's what usually happens. For them to conduct electric current, they must be dissolved in water. And when they are dissolved in water, they tend to form hydrated ions. If the ion gets hydrated and the hydrogen ion also gets hydrated, then you see such conductors tending to conduct electric current. Such electrolytes, not conductors, tend to conduct electric current after their ions are hydrated. And these include amino acids. Amino acids, that's the way they do conduct electric current. The other key point I want us to look at under electrochemistry is what we call electrodes. What are electrodes in electrochemistry? So these are conductors that carry electric current in and out of the cell. That carry electric current in and out of the cell. They are divided into two. We have what we call the anode, and we have what we call the cathode. These are not new to us. What's the anode? At the anode, oxidation occurs. And you know what oxidation is? Oxidation is loss of electrons. I normally use oil for me to remember it. Oxidation is loss of electrons. The cathode is where reduction occurs. And reduction is gain. I normally use rig to remind me that reduction is gain of electrons. So from those terms, I can get the definitions of each. And therefore I can define the anode as the electrode at which oxidation occurs, or the electrode at which loss of electrons occurs. And therefore the cathode as the electrode at which reduction occurs, or at which gain of electrons occurs. Are we together?
Yes, teacher.
All right. Which changes take place during electrolysis? We want to see which changes take place during electrolysis. Changes that take place during electrolysis. I'll draw what I call an electrolytic cell. Remind you your O-level work. Electrolytic cell. If I'm to draw an electrolytic cell, I'll have something like this. Don't get worried of my diagram. You can draw it better than mine. My electrodes are already corroded. I know you can do better than these ones of mine. Now, these electrodes are always dipped in an electrolyte. And each of them is connected to, by connecting wires to a DC power source or a battery. This long terminal here is always what we call the positive terminal of the battery, and the shorter one is what we usually call the negative terminal of the battery. Now, the positive terminal of the battery is always connected to an electrode called the anode. And the negative terminal is always connected to an electrode called the cathode. So those two are the electrodes. Then inside here, we have our electrolyte. We already said this is our battery. Having known how, this is what we call an electrolytic cell. I don't want you to confuse it with what we call an electrochemical cell. We shall see the electrochemical cell later. That is an electrolytic cell. What happens? The electrolytic cell is set up as shown. The cell is set up as shown. Now, this electrolyte you see here usually consists of both cations and anions. We say it's not entirely ionic, it can be an ionic electrolyte or a covalent electrolyte. But at the end, whether ionic or covalent, ions must be there. And we said with ionic electrolytes, they are formed by dissociation or ionization, and then with the covalent electrolytes, they are formed by hydration or solvation with water. So electrolyte, our electrolyte in there contains cations and anions. So what happens during electrolysis? During electrolysis, those ions migrate to either the cathode or the anode. The cations migrate to the cathode. I think you see some similarity here. Cations, cathode. The anions migrate to the anode. Remember, cations are positively charged, anions are negatively charged. I don't want to say the cathode is negatively charged, I'm avoiding it. Even the anode is, I don't want to say it's positively charged because it confuses you. That's very true. In the electrolytic cell, the cathode is negatively charged and the anode is positively charged. But when we come to an electrochemical cell, we shall see that it's the opposite. The cathode is positively charged and the anode is negatively charged. We shall see that when we come to an electrochemical cell. So, electrolyte contains cations and anions. During electrolysis, cations, the ions are discharged. Okay? So the anions migrate to the anode and the cations migrate to the cathode. What happens at the cathode? The cations combine with the electrons. Or you can say are reduced to form neutral elements. That's the whole theory of electrolysis that we are explaining. So cations combine with electrons to form neutral electrons. So if my cation is Cn+, then it must combine with N electrons to form the neutral elements. And this process is involving gain of electrons, which we are calling reduction. Then the anions migrate to the anode. So when anions migrate to the anode, what happens there? They lose electrons, which we are calling oxidation, to form neutral elements. The elements formed there can be neutral, like a chlorine gas, or may form new molecules. Generally, if this is my anion, An-, can be aqueous or liquid, it will lose electrons to form A, can be in Na physical state, I may not consider that, then plus N electrons. That's the whole theory of electrolysis. So in this episode, we have looked at key terms, electrolysis. Then we have also looked at the theory of electrolysis. Next, let's see the principles of electrolysis.